The stealth AI payload, Chrome's 4 GB secret. Google's deployment of Gemini Nano as a forced local installation raises urgent questions about user autonomy and system integrity. The discovery that Google Chrome may have surreptitiously downloaded a 4 GB file associated with the Gemini Nano large language model marks a critical inflection point in the battle between cloud convenience and local sovereignty.
While Google frames this as a step toward on-device AI enabling faster, privacy-preserving inference, the lack of opt-in transparency transforms an efficiency upgrade into a potential vector for uncontrolled storage, consumption, and system vulnerability. This move forces the market to confront a paradox. A browser, traditionally a lightweight intermediary, is becoming a heavyweight platform capable of executing complex AI workloads, often without the user's explicit awareness.
The strategic situation is one where the promise of edge AI collides with the harsh realities of digital consent and device resource management.
The browser as a covert operating system. This incident underscores a broader trend where browsers evolve into self-contained execution environments, challenging traditional security and control paradigms. Historically, browsers served as portals to remote servers, but the ascent of WebAssembly and progressive web apps has blurred the line between client and server.
Google Chrome now acts as a de facto operating system for web applications, and the inclusion of Gemini Nano, a multi-gigabit neural network model, represents the logical conclusion of this evolution. The underlying driver is Google's strategic imperative to maintain dominance in AI by shifting inference to edge devices, thus reducing reliance on cloud infrastructure and circumventing privacy regulations.
However, the 4 GB hidden file revelation highlights a critical tension. Without explicit notification, users become unwilling hosts to a complex software stack that is difficult to audit and potentially exploitable. The status quo is untenable. We are entering an era where browsers demand the same level of scrutiny as any installed software.
RCE risks and the unpatched attack surface. The combination of a large, opaque AI model and Chrome's broad execution context creates a new class of exploitable attack vectors. The tag RCE remote code execution is not accidental. The deployment of a 4 GB binary model inside a browser's sandbox exponentially increases the attack surface.
Gemini Nano, while optimized for on-device generation, relies on WebNN and WebGPU APIs that can be abused if not properly hardened. Moreover, the model files themselves, often containing SAF tensors or proprietary formats, could become targets for model poisoning or backdoor injection if the download channel is intercepted.
Google's lack of granular user control over when and how this model updates or runs means that a single vulnerability in the Mojo or Blink rendering engine could permit an attacker to trigger the model, consume system resources, or exfiltrate process data. The interplay between a large static AI payload and a constantly evolving browser creates a moving target for security researchers, but also a persistent shadow risk for enterprise environments where Chrome is the primary browser.
The new digital frontier, consent vs. inevitability. The 4 GB file will catalyze regulatory scrutiny and push users toward more transparent AI architectures or alternative browsers.
The long-term consequence of this event is a mandate for radical transparency in how browsers manage local AI resources. We anticipate that regulatory bodies like the EU under Digital Markets Act will investigate whether Chrome's silent download violates user autonomy, potentially forcing Google to implement explicit opt-in dialogues and storage budgets.
Simultaneously, competitors such as Edge with Copilot and Firefox with its own integrated AI will be pressured to match or exceed Chrome's local performance, but must differentiate through user empowerment. For enterprises, the projected response is a zero-trust policy for browser installations, treating Chrome's model folder as a critical asset requiring monitoring.
The future projection is that within 12 months, A new standard for AI manifest files will emerge, detailing model size, version and update frequency akin to a nutritional label for software. Google will either lead this standardization or face a fragmented ecosystem where user trust erodes, slowing adoption of on-device AI across the web platform.